Okay, so the question reads, consider 4-point charges located at the corners of a square as shown. List all the locations where the E field is 0, and then B is list all locations where electric potential is 0. So let's start off with A. So the electric field due to a point charge is 1 over 4 pi epsilon naught multiplied by the charge over the distance squared. So the electric field is 0 only at infinity. So when R is infinity, our electric field is equal to 0. So that is the answer for A. Okay, now say we have 2-point charges. 2-point charges, Q1, which is just equal to Q, and Q2, which is equal to negative Q. They're a distance A away. We want to find electric potential at point P. So Q1 is a distance x away from point P, and then Q2 is a distance A minus x. A minus x. So the potential due to a charge is V1 equals KQ1 over x, and the potential due to second charge is KQ2 over A minus x. V1 plus V2 is equal to KQ1 over x plus KQ2A minus x. We want the potential to be 0, so we write 0 there. We then just subtract negative KQ1 to the other side. Since K is a constant, just take that out. So then we get negative Q1 over x equal to Q2A minus x. We then cross multiply. I'm going to make room here. Cross multiply, and you get Q2x is equal to negative Q1a plus Q1x. We're gonna just rearrange this and get Q1, so subtract Q1a to the other side. And then we get x, Q1 minus Q2. And then we get its x is equal to Q1a over Q1 minus Q2. And then since Q1 is just equal to Q, we get Q over A, and then we get Q minus negative Q, for Q2 is negative Q, and that's just 2Q. And then the Q's cancel out, and then we're left with A over 2. So the potential is 0 when x is equal to A over 2 between a positive charge and a negative charge that have the same that between a positive and negative charge. According to this access, it should be y is equal to A over 2, but I used x because I defined this as my x. But according to this figure right here, it would be y is equal to A over 2 because there would be a positive charge here and then a negative charge here. And then that's 1 point. The other point where potential is 0, so our potential equation is V equals KQ over R. When R goes to infinity, our potential is 0. So that's another point, infinity and A over 2. And that is it for this problem.